In this video clip, we will learn about how to evaluate trigonometric functions when the angles are the sum or difference of well-known angles, such as 30, 60, 45, 90, 135 degree, and so on, which we know the trigonometric function values. To do that, we will use addition or subtraction formulas. Let me write down the formulas which you have to remember. Sine of s plus or minus t equals sine of s times cosine of t plus or minus cosine of s times sine of t. Let me explain the notation. Plus or minus it can be plus or minus. I'm writing two different formulas in one formula. So that means sine of s plus t is sine of s times cosine of t plus cosine of s times sine of t. So plus will be combined with plus and minus will be combined with minus. So sine of s minus t equals sine of s times cosine of t minus cosine of s times sine of t. So these two formulas are condensed in this one formula. Cosine formula is cosine of s plus minus t equals cosine of s times cosine of t minus or plus sine of s times sine of t. We do the similar thing to interpret this formula. In this case, plus will be combined with minus and minus will be combined with plus. So the meaning of that formula is cosine of s plus t equals cosine of s times cosine of t. This time the middle sign has changed, become minus. Sine of s times sine of t. The cosine of s minus t equals cosine of s times cosine of t minus became plus sine of s times sine of t. So that's the meaning of this formula. There is a formula for tangent. Tangent of s plus or minus t equals tangent of s plus or minus tangent of t over 1 minus plus tangent of s times tangent of t. Here, two formulas are involved. So tangent of s plus t equals tangent of s, upper part is plus tangent of t over 1, lower part. Then the denominator again take the upper part, and then it'll be 1 minus tangent of s times tangent of t. the other formula is tangent of s minus t equals, again, we are chasing the bottom one. Then the numerator becomes tangent of s minus tangent of t over 1. The lower one is 1 plus tangent of s times tangent of t. So this formula is the condensed form of this formula. You can understand the nature of the formula a lot better if you work on the problems. Find the exact value. The first problem is sine of 75 degree. These are not 30, 45, 60 degree, 90 degree, or anything close to those well-known angles, but we can still list the well-known angles to use the sum and difference formula. Well-known angles, this is a small angle, so let's list 30 degree, 45 degree, and 60 degree, and so on. Then we realize that if we add them, then it'll give 75 degree. So the way we interpret the angle 75 degree will be the sum of 30 degree plus 45 degree. If you look at the formula, then sine formula combines sine and cosine. The middle part will be preserved, and then cosine times sine, sine times cosine, and then cosine times sine. So we will use this formula. Then it'll be sine of 30 degree times cosine of 45 degree plus cosine of 30 degree times sine of 45 degree. So we have two triangles. (30, 60, 90 degree triangle. This is 30 degree, and this is opposite, and this is adjacent. And 45, 45, 90 degree. This is 45 degree, and 1, 1, square root of 2. Let's do substitution. Sine of 30 degree opposite is 1, so 1 over 2 times cosine of 45 degree is 1 over square root of 2 plus cosine of 30 degree is adjacent is square root of 3, so square root of 3 over 2 times sine of 45 degree is 1 over square root of 2. In this case, we can rewrite 1 over square root of 2 by rationalizing. Then that is square root of 2 over 2. So this becomes 1 over 2 times square root of 2 over 2 plus square root of 3 over 2 times square root of 2 over 2. So the final answer will be 4 in the denominator, and the numerator will be square root of 2 plus square root of 6. The next problem is sine of 43 pi over 12. In this case, the given angle is a big angle. Then we will use coterminal angle property. Which means coterminal angles will have the same trigonometric function value. Apparently, 43 pi over 12 is larger than 12. Let's fix 2 pi into the fraction over 12. The denominator is 12 and the numerator is 24 pi. So if we think about the coterminal angle, then we can say 43 pi over 12 equals 24 pi over 12. If you think about 43 minus 24, then that'll give you 19. So that is 19 pi over 12. So those two are the coterminal angles. So we can write sine of 43 pi over 12 is the same as sine of 19 pi over 12. By using the coterminal angle property, we can reduce the angle, which we can evaluate a little bit easier, but 19 pi over 12 is still large. So let's subtract 2 pi to get the coterminal angle. Then that'll become 19 pi over 12 minus 24 pi over 12. The difference between 19 and 24 is 5, and the larger number has negative, so that is minus 5 pi over 12. So this time we can say 19 pi over 12 equals minus 5 pi over 12. Let's summarize what we obtained so far. The problem is given as sine of 43 pi over 12. We figured out that the angle is coterminal to 19 pi over 12. So the sine values are the same. And then we did further. 19 pi over 12 is the coterminal angle with minus 5 pi over 12. Here, we can use the odd function property for sine. then this minus can be written in front of sine, so it becomes minus sine of 5 pi over 12. This fraction is a lot smaller and simpler than the angle which is given in the problem. So it'll be a lot easier to figure out. But this angle is not well-known angle. So what we want to do is we want to combine the well-known angles by sum or difference to use the formula. Before we do that, we will list the well-known angles. Those are like pi over 2, pi over 3, and pi over 4, and pi over 6, and so on. Then what we notice is the denominator is 12. So we will think about the common denominator, and common denominator is apparently 12. So pi over 2 can be written as 6 pi over 12, and pi over 3 can be written as 4 pi over 12, and pi over 4 can be written as 3 pi over 12, and pi over 6 can be written as 2 pi over 12, and so on. Those two are the same, and so we want to make 5 pi over 12 by combining two of them. If we add these two, then we will get 5 pi over 12. If we rewrite that, then this is the reference. Then we go with this equal, then minus sine of 5 pi over 12 can be written as 3, just a pi over 4 plus pi over 6. We don't use this anymore because well-known angles are pi over 4 and pi over 6. Once we figure out how to express the given angle with sum or difference of the well-known angles, we can just apply the sum or difference formula. Here is the sum formula for sine. So we start with, so minus is in front of the bracket. Then we start with sine. So sine of pi over 4 times cosine of pi over 6. The same plus will become plus, then cosine of pi over 4 times sine of pi over 6. So that is minus sine of pi over 4 was 1 over square root of 2, and we could rationalize it as square root of 2 over 2, times cosine of pi over 6 is square root of 3 over 2, plus cosine of pi over 4 is again square root of 2 over 2, times sine of pi over 6 is 1 over 2. We have the denominator 4. Those are common denominator, so we can combine all two terms together with the common denominator 4. Then the first one will be square root of 2 times square root of 3, which is square root of 6. plus square root of 2. The next problem is cosine of 195 degree. This time, we will think about sum or difference formula with cosine function. The first thing you can notice from the number, which is given here, is the last digit is 5. If the last digit is 5, then that is always related to the angle 45 degree. So the way we will break it down will be 195 degree is 45 degree plus 150 degree. So those two are added. So plus becomes minus. This time we are using the sum formula for cosine. That combines cosine with cosine and it starts with cosine. So that becomes cosine of 45 degree times cosine of 150 degree. When it comes to cosine, plus became minus, so you have to be careful. This became minus. And then combine sine with sine. Sine of 45 degree times sine of 150 degree. In this case, we have to use the well-known angles identity combined with the reference angle. If we locate 150 degree in the quadrant, then that's in the second quadrant. The reference angle is 30 degree. In the second quadrant, cosine is negative and sine is positive. So when you evaluate sine of 150 degree, that is plus or minus sine of its reference angle, but in the second quadrant, that is greater than 1 or greater than 0. So we don't put minus here. So sine of 150 degree equals sine of 30 degree, which is 1 over 2. Then we evaluate cosine of 150 degree. That is again plus or minus cosine of 30 degree. In the second quadrant, cosine is negative, so we have to put minus sign here. And the function value was square root of 3 over 2. Let's keep on going. Cosine of 45 degree is square root of 2 over 2 after rationalization. Cosine of 150 degree was square root of 3 over 2. Minus sine of 45 degree is square root of 2 over 2 times sine of 150 degree is 1 over 2. So here, I dropped minus here. So I have to put minus here. Then it is minus square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1 over 2. They have common denominator 4 and minus are attached to each term. So we can put minus in front of fraction, and then square root of 2 times square root of 3 is square root of 6 plus square root of 2, because we already took out minus here. So that's the final answer. Here, minus is applied to both because that there is a hidden parenthesis there. Let's do the next example. The next example is cosine of 29 pi over 12. Again, the denominator is 12, and 29 pi over 12 is pretty large. And we already know that 2 pi with denominator 12 is 24 pi. So we want to reduce that angle by finding the coterminal angle. So let's subtract 2 pi, then 29 pi over 12 minus 24 pi over 12. That is 5 pi over 12. So from here, we can say that these two are coterminal angles. And then we can conclude that cosine of 29 pi over 12 is the same as cosine of 5 pi over 12. What we want to do is we want to think about the well-known angle to get 5 pi over 12 instead of 29 pi over 12, because we know the smaller number. I said the first step to do it is listing the well-known angles, pi over 2, pi over 3, pi over 4, and pi over 6, and so on. And then when the denominator is given as 12, then you will think about the common denominator with all of these. The common denominator is 12, so we will convert the fraction into over 12. Then pi over 2 can be written as pi over 6 pi over 12. Pi over 3 can be written as 4 pi over 12. And pi over 4 can be written as 3 pi over 12. And pi over 6 can be written as 2 pi over 12. So we have to use these two. If we add them up, then we will get 5 pi over 12. So we have to add pi over 4 and pi over 6. Let me write the problem again. Then cosine of 29 pi over 12 had the same value as cosine of 5 pi over 12 because those are coterminal angles. And then we express that with the sum of two angles, which are pi over 4 and pi over 6. Once angles are combined, all you have to do is you will use the formula. Again, plus becomes minus, and cosines are combined and sines are combined. So we can rewrite that as cosine of pi over 4 times cosine of pi over 6 minus sine of pi over 4 times sine of pi over 6. Then all we have to do is evaluating. When it comes to cosine, plus becomes minus, so you have to be careful. So square root of 2 over 2 times cosine of pi over 6 is square root of 3 over 2 minus sine of pi over 4 is square root of 2 over 2 times sine of pi over 6 is 1 over 2. If you don't remember it, then you have to draw the triangle to figure that out. But at this point, I'm expecting you to remember the special triangles in your head, and you can visualize it to evaluate the function value. Those are the common denominator is 4. The first term is square root of 6 minus square root of 2. Let's move on to the next problem. The next problem is about tangent. Tangent of minus 17 pi over 12. 17 pi over 12 is pretty big fraction. So this time what we will attempt to do will be we will attempt to add 2 pi because that is minus value to figure out the coterminal angle. Then it'll become minus 17 pi over 12 plus 24 pi over 12. So we can reduce that to 7 pi over 12. So those two turned out to be coterminal angles. That implies tangent of minus 17 pi over 12 is the same as tangent of 7 pi over 12. Therefore, we will work on tangent of 7 pi over 12 instead of the larger negative fraction with minus 17 pi over 12. As we did, we will think about the well-known angles. Those were pi over 2, pi over 3, pi over 4, and pi over 6, and so on. The common denominator was 12, and we could rewrite that as 6 pi over 12, 4 pi over 12, and 3 pi over 12. The next one is 2 pi over 12. We have to do something to make 7 pi over 12. We can add digit 2. Then that'll be 7 pi over 12. That means we have to take 3 pi over 3 and pi over 4 and add them up. Let me rewrite the problem and what we have been doing. Tangent of minus 17 pi over 12 was the coterminal as 7 pi over 12, so the same as tangent of 7 pi over 12. That can be rewritten as tangent of pi over 3 plus pi over 4. After you figure out the angle combination, all you have to do is you apply the formula. So that equals tangent of, for the numerator, the order is the same. So tangent of pi over 3 plus tangent of pi over 4. And then plus becomes minus. So 1 minus tangent of pi over 3 times tangent of pi over 4. So it becomes a little bit harder to figure out the tangent value without looking at the special triangle. So let's draw the special triangle. Pi over 3 is here. This is opposite and this is adjacent. Again, this is opposite, this is adjacent. So from here, we get tangent of pi over 3 equals opposite is square root of 3 over adjacent is 1. So that is square root of 3. And here, tangent of pi over 4 equals opposite, which is 1 over 1, which is 1. So let's do substitution. Tangent of pi over 3 is square root of 3 plus tangent of pi over 4 is 1 over 1 minus tangent of pi over 3 is square root of 3 times tangent of pi over 4 is 1. So that equals square root of 3 over plus 1 over 1 minus square root of 3. I'm not sure whether Sine will accept this answer or not, but in this particular case, if we rationalize it, then the answer looks better. So let's do that. Rationalizing this kind of fraction can be done by multiplying the conjugate of the denominator, meaning we just switch the sign in the middle and then multiply it to the numerator and the denominator. Let's calculate square root of 3 plus 1 times square root of 3 plus 1. I just switch the order. You can just FOIL if you don't remember the square formula. Square root of 3 times square root of 3 will give you 3 plus square root of 3 times square root of 3 plus 1. 3 plus 1 is 4 plus square root of 3 plus square root of 3 is 2 square root of 3. The next one is 1 minus square root of 3 times 1 plus square root of 3. We will do FOIL again, and then it'll be 1 plus square root of 3 minus square root of 3 minus 3. So these two will cancel each other, then it becomes minus 2. So if we combine these two, this is the numerator, this is the denominator. So we can rewrite that as 4 plus 2 square root of 3 over minus 2. If you just multiply by 1/2 on the numerator and denominator, then those two will cancel each other, and denominator becomes minus, so minus, and that was the fraction, so open parenthesis. The u do distribution, then 4 times 1/2 will give you 2 plus 2 times square root of 3 times 1 over 2 will give you square root of 3. So either this or minus 2 minus square root of 3 will be the answer. For Weber sine, I'm not sure whether I believe all of them will be accepted. Otherwise, they gave you any other instruction. In the remaining problems, we will do the reversing process. We want to find the exact value. The first problem is given as sine 14 degree times cosine 31 degree plus cosine 14 degree times sine of 31 degree. Different from the process we took from the left to right, this time we have to go from the right to the left. In this case, sine and cosine are combined, and this is not the fraction. So what we can imagine is that is related to sine. Then angle 14 and 31 is combined. Then we have to think about whether we connect that with plus or minus. As you can see, the formula goes plus to plus, so we will combine those two angles with plus. So that is sine of 45 degree. That is 1 over square root of 2 or square root of 2 over 2. The second question is cosine of 13 pi over 15 times cosine of minus pi over 5 minus sine of 13 pi over 15 times sine of minus pi over 5. In this problem, cosine are combined together, sines are combined together. So we have to use the cosine related formula, and the middle part is minus. Then in the parentheses, the two angles must be added. So we have cosine of 13 pi over 15, then minus becomes plus, plus the angle itself is given as minus, so minus 5 pi over 5. So we have to combine those angles. Cosine of 13 pi over 15, we think about the common denominator, that is 15, and we can just write minus in the middle. To get 15, we have to multiply by 3, so the numerator will become 3 pi. So when we reduce that, that will become 10 pi over 15, and 10 is 2 times 5, and denominator is 3 times 5, and this 5 and this 5 will cancel each other. So that will be cosine of 2 pi over 3. When we locate the angle on the quadrant, this is pi, which is 3 pi over 3. So 2 pi over 3 is in the second quadrant. 2 pi over 3. And then the reference angle will be pi over 3. And then we have to figure out whether that is minus or plus. So here, cosine of 2 pi over 3 is plus or minus pi over 3, because this angle is the reference angle of 2 pi over 3. That is determined with the sign of cosine. That is less than 0, so that is minus. So that is minus 1 over 2. Third one is about tangent related formula. Tangent of pi over 18 plus tangent of pi over 9 over 1 minus tangent of pi over 18 times tangent of pi over 9. Obviously, we have to combine the angle, and the designated trigonometric function is tangent. If you look at the formula, the numerator preserves plus to plus, but denominator switches the sign. So we just look at the numerator, then combine the two angles, pi over 18 plus pi over 9, and then we will calculate the angle to see which angle we are getting. The common denominator is 18, so pi over 18 plus 2 times 9 will make 18, so 2 pi over 18. So we get tangent of 3 pi over 18. So that is tangent of pi over 6. Let's draw the triangle. Here is pi over 6, 1, 2, square root of 3. This is opposite, and this is adjacent. And tangent is opposite over adjacent, so that is 1 over square root of 3. So the final answer is 1 over square root of 3.